Hello everyone, once again welcome back to this channel. In this video we are going to start three-dimensional geometry, a chapter from class 12th mathematics. This is going to be a very important chapter from examination point of view, not just board exam. This chapter has a very huge weightage in NDA exam. Around 8 to 10 questions are asked from here in NDA exam, and also I can say this chapter will get a score very good in your JEE exam as well, right? If we talk about class 11th, there was a chapter straight line. In that chapter we learned how to find the equation of a straight line in a two-dimensional space, right? X-axis, y-axis, the angle between two lines, distance of a point from a line. All these concepts we have learned in straight line, but that chapter was limited up to two-dimensional space only, right? But here in class 12th mathematics, in this chapter we will learn how to find equation of a straight line in 3D space, how to check if two lines are intersecting or not, how to find the distance between two non-intersecting and non-parallel line in 3D space, not just straight line. We will talk about plane, how to find the equation of a plane in a 3D space, right? So all these kind of concepts we will cover in this chapter. Okay, so guys, let's get started. Okay, so guys, this is the first concept of this chapter, this video, line in a 3D space. If we talk about two-dimensional geometry, a straight line used to look like this, right? This is x-axis, y-axis, and these two axes divide the entire space in 4 quadrants, right? And suppose there is a straight line, then what will be the standard form of this line? The answer is, the standard form used to be ax plus by plus c equal to 0. But this is the equation of line in two-dimensional geometry. If we talk about 3D space, let's say this is x-axis, y-axis and z-axis, and we know that the entire space is divided in 8 octants by these 3 lines, right? And we know that these 3 lines are mutually perpendicular to each other. And suppose there's a line in this 3D space and we have to find the equation of this line. Now there are 2 methods of finding the equation of this straight line, and after applying the formula we get a standard form, r vector equal to a vector plus lambda b vector. Now this will be the general form, standard form of a straight line in 3D space. This equation contains some vectors, a vector, b vector, r vector. This terminology will be discussed later in this video, okay? But first of all, we need to understand that every straight line will be in this form, okay? This straight line is represented in the form of vectors. So this is called vector equation of straight line in 3D. And this can also be represented in the form of x, y and z. And this line will look like x minus x1, y minus y1, z minus z1 upon a, b and c. And this equation is called Cartesian equation of line. So in 3-dimensional geometry, a line, a plane, the equation can be represented in 2 ways, vector form and Cartesian form, right? The vector equation of the line is r vector equal to a vector plus lambda b vector, x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. So now question is, what is the meaning of a, b and c, a vector and b vector? Okay, so let's understand this. Suppose concept 1, equation of line when it passes through a point A, x1, y1, z1 and parallel to vector b ai plus bj plus CK, right? Let's say there is a straight line which is passing through the point A, and the coordinates of A are x1, y1 and z1, right? And this line is parallel to a vector B, whose direction ratios are AI, BJ and CK. This line and this vector, they both have same direction. They both are moving in same direction, okay? Because we know that when we talk about a single point, there are infinite lines which will pass through this specific point, okay? And if we want the equation of a particular line, so this single point will not help. We also need the direction vector, okay? So this point and this parallel vector will be given in the question, okay? So now, how do we find the equation of this line? So for finding the equation, we will assume that there's a general point R on this straight line, and the coordinates of R will be x, y and z. This is a general point on this straight line. We know that there are infinite number of points on this line, right? So every point will be represented by this general point R, x, y and z, right? Okay, so now guys, if we join this point A with R, we will get a vector AR. If this point A and R are joined, then we'll get a vector AR. And this AR and this vector B, they both have same direction, are in same direction. And whenever two vectors are in same direction, whenever they are parallel or collinear to each other, in that situation, one vector will be lambda times of other vector. One vector will be lambda times of other vector. Let's say the magnitude of vector B is 5 unit, and the distance between point A and point R is also 5. In that situation, AR will be 1 times of B. We can simply say that both the vectors AR and B both are equal vector. Suppose the distance between point A and point R is 10 units, then in that situation AR will be twice of B. Suppose the distance between A and R is 20 units, then in that situation AR will be 5 times of B. Suppose the distance between A and R is 10 units, but this R is not in the right side of A. This R is in left side of A. And now this distance is 10 units. But in this case, vector AR and vector B, they both have opposite direction. They are anti-parallel, right? So in that case, since the magnitude of AR is 10 unit and the magnitude of B is 5 unit, so AR will be twice of B. But since they have opposite direction, they are anti-parallel, in that situation, this lambda will be -2. So lambda can be any real number. It can be 0, it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It can be negative, it can be positive. Okay. In what situation lambda will be 0? Suppose this R and this point A, point R and point A both coincide. Point A and point R both coincide, right? So in that situation, AR will be 0 times of B. Okay. When A and R both coincide, in that situation lambda will be 0, right? Okay. So guys, this is the meaning of lambda. Lambda can take any real value, right? Okay. So now we have this point A and a general point R on this straight line, and this AR and vector B, they both have same direction. So AR vector is lambda times of B. Lambda can be any real number, right? So now what should be the vector AR? This AR was made by joining point A and point R. So we can say this AR is the position vector of R minus position vector of A and which is equal to lambda times of B. Right? Suppose there are 2 points. Point A is 1 and 2 and point B is 4 and 1. So now what will be AB vector? In this situation, we subtract 1 from this 4 minus 1 I cap and 1 minus 2 j cap. Similarly, we can find AR vector by subtracting A from R, that is position vector of R minus position vector of A. हमने R में से इस A को यहाँ पे subtract करना है. Okay, so let's say the position vector of R is represented by small r and position vector of A is represented by small a, which is equal to lambda times of B, and now the R vector is equal to A vector plus lambda times of B vector, and this is the vector equation. This is the vector equation of a straight line. हमने यहाँ पर भी वही देखा था कि straight line की vector equation R vector equal to A vector plus lambda B vector होगा, और वो कैसे होगा ये हमने यहाँ पे देखा, right? But there is another equation in terms of x, y, z. This vector equation contains vectors A vector, B vector, but there is another equation which is Cartesian equation. Vector equation is in terms of vector and Cartesian equation will be in terms of x, y and z. So how do we find Cartesian equation? So guys, in this situation, as we all know that AR vector and B vector both are in same direction. We can say both the vectors are parallel to each other. Both the vectors are collinear to each other, and we know that whenever two vector A vector and B vector are collinear, then their direction ratios will be proportional, right? So the direction ratios of AR will be, if we talk about direction ratios of AR, then answer will be x minus x1, y minus y1, and z minus z1. And what are the direction ratios of B vector? Direction ratios of B vector: A, B, and C. And since these two vector AR and vector B, both the vectors are collinear, parallel, and they both are in same direction, so these direction ratios will be proportional, right? Like A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. So x minus x1 upon A, y minus y1 upon B, and z minus z1 upon C, all these terms will be equal to some constant lambda, and this is called the Cartesian equation. This is the Cartesian equation of a line. This is the Cartesian equation of a line. For example, let's say there was a line which was passing through point A, and the coordinates of A were 2, minus 3 and 6, and there is a parallel vector, and there is a parallel vector B which is 4i plus 5j minus k. Okay, and now we have to find the equation of line. This is a parallel vector and this is the straight line. Okay, so now equation of line which is passing through point A and which is parallel to this vector B. Formula is, vector equation is R vector is equal to A vector plus lambda B vector. Now A vector, this A vector is the position vector of the point through which line passes. So A vector will be 2i minus 3j plus 6k plus lambda. Now we have B vector. This B vector is the parallel vector which tell about the direction in which the straight line is moving. Okay, so the B vector is given in this question, 4i plus 5j minus k. So guys, this is the vector equation of the line. Vector equation of line. But if we talk about Cartesian equation, the formula is x minus x1 upon a, y minus y1 upon b, z minus z1 upon c, right? x1, y1, z1 are the coordinates of the point through which line is passing. As you can see, this line is passing through x1, y1, z1, and in this situation line is passing through 2, minus 3 and 6. So x1 is equal to 2, y1 is equal to minus 3 and z1 is 6. So according to this equation, x minus 2, now minus 3 will be subtracted from y, so y minus minus 3, which will become y plus 3 in the next step, z minus 6, and in denominator we have direction ratios a, b, c, small a, small a, small b and small c. Small a, small b and small c are the direction ratios of the parallel vector. 4, 5 and minus 1. 4, 5 and minus 1. So guys, this is the Cartesian equation. Of line. So guys, this was the first case of finding the equation of a line when it was passing through one given point and it was parallel to a given vector. Okay, but suppose there is a situation when line is passing through 2 points. Point A, x1, y1, z1, and point B, x2, y2, and z2. Right? Okay. So there is no parallel vector in this situation. There is a point A and point B. Coordinates of A are x1, y1, and z1, and the coordinates of B are x2, y2, and z2. No parallel vector is given in this situation, right? So guys, for finding the equation of AB, again we will have to let a point on this line. Let's say there is a point R, a general point. Coordinates of R are x, y, z. This is a general point. This is a general point on this straight line. And now we have to find equation of a line which is passing through point A and point B. Okay. So if we join point A with point R, we will have AR vector, right? If I join A with this B, I will have a vector AB. So AR vector and this AB vector, vector AR and vector AB, both are collinear. They both lie on this same straight line. Okay. So again, same rule, whenever two lines are parallel or collinear, one vector will be lambda times of other. One vector will be lambda times of other vector. So AR vector is equal to lambda times of AB, and now this AR can be written as position vector of capital R minus position vector of capital A, and now which is equal to lambda times of position vector of point B minus position vector of point A. Okay, so now let's say the position vector of capital R is small r, position vector of this capital A is small a, and the position vector of this capital B is small b. So guys, position vector of capital R, answer is small r minus small a, which is equal to lambda times of small b minus small a. So now this will become R vector equal to इस a को राइट में ट्रांसफर करेंगे, सो ये राइट में जाके पॉजिटिव हो जाएगा, प्लस a प्लस लैम्डा टाइम्स ऑफ b माइनस a, एंड गाइस दिस इज द वेक्टर इक्वेशन ऑफ अ लाइन. This is the vector equation of line when it passes through two given points. Okay, so now the terminology has been changed. In this situation, the small a vector represents the first point through which line is passing. Okay, and this small b vector, this small b vector is representing the position vector of second point through which line is passing. Earlier, this small b vector used to represent parallel vector. Earlier, it used to represent parallel vector, right? But now in this situation, this small b vector represents the position vector of second point through which line is passing, right? So guys, this is the vector equation of a line when it is passing through 2 points. R vector equal to small a vector plus lambda b vector minus a vector, right? Okay, so now this equation can be converted into Cartesian form. The method will be same. As you can see, this AR and AB both are collinear. AR and AB both are collinear, and whenever two vectors are collinear or parallel, their direction ratios are proportional, right? So what are the direction ratios of AR? Direction ratios of AR. Direction ratios of AR. So direction ratios will be x minus x1, x minus x1, y minus y1, and z minus z1. And what are the direction ratios of AB? Direction ratios of AB, answer is x2 minus x1, y2 minus y1, z2 minus z1. x2 minus x1, y2 minus y1, and z2 minus z1. And this is the Cartesian form of a line when it passes through 2 points. For example, let's say we have to find the equation of a line which is passing through 4, 1, minus 5, and 2, 3, 2, minus 3, and 6. This is point A and this is point B, and we have to find equation of this line, right? So let's say the coordinates of 4, 1, minus 5, let's say these are x1, y1, and z1. This point B will be x2, y2, z2. The formula for finding the equation is a vector plus lambda b vector minus a vector. So value of a vector, this is 4i plus j minus 5k plus lambda. B vector, this is 2i minus 6j plus 6 plus 6k. Now a vector will be subtracted from this, 4i plus j minus 5k. So now this will become 4i plus j minus 5k plus lambda. 2i minus 4i, answer is minus 2, minus 6 and minus 1, this is minus 7, 6 plus 5, this is 11k. Guys, now this is the vector equation of a line. Now you can convert this equation into Cartesian form. We have the formula for equation of line when it passes through 2 points. Formula is x minus x1, y minus y1, z minus z1 divided by x2 minus x1, y2 minus y1, and z2 minus z1. So putting the values in the formula, we will have x minus 4, y minus 1, and z minus 5 divided by x2 minus x1. So 2 minus 4, this is minus 2, minus 6 and minus 1, this is minus 7, and 6 plus 5, now this is 11, and which is equal to lambda. So guys, you can see this is the Cartesian equation of the line. वेक्टर इक्वेशन और कार्टेशियन इक्वेशन को आप देखेंगे तो आपको यहाँ से पता चलेगा कि जैसे पहले यहाँ पे क्या है, ये दिस इज 4i plus j minus 5, 4, 1 and minus 5. These 4, 1 and minus 5, these terms are subtracted in numerator. You can see 4, 1 and minus 5. They are subtracted from x, y, z, right? And whatever be the coefficients of I, j and k with lambda. Lambda के साथ ये जो वेक्टर है और यहाँ पे जो भी I, j और k के coefficients हैं, they will be in denominator like minus 2, minus 7, 11, minus 2, minus 7 and 11. Same in the previous question. You You can compare this vector equation and Cartesian equation. 2 minus 3 and 6 will be subtracted in numerator. 2 minus 3 and 6, all these terms are subtracted in numerator from x, y and z respectively, and the coefficients of I, j and k with vector with lambda 4, 5 and minus 1, they will be in denominator 4, 5 and minus 1. So we can say if a vector equation is given to us, let's say vector equation is 2 plus 5 minus k plus lambda 3i plus 2j plus 3k. So can we convert this equation into Cartesian form? So answer is yes. In numerator 2, 5 and minus 1 will be subtracted from x, y and z, and in denominator we will have 3, 2 and 3, 2 and 3. So guys, this is equal to lambda, and this is the Cartesian form of the line. Okay, so guys, this is how we find the equation of line in 3-dimensional geometry. Okay, so now moving to next concept. What is the method of finding the angle between two lines? Angle between two lines. The method is, suppose there are two lines, first and second, angle between them is theta. There are two lines, r vector equal to, first line is a1 vector plus lambda b1 vector, and the second is r equal to a2 vector plus mu b2 vector. Okay, this first line is passing through the point with position vector a1, and the second line is passing through the point with position vector a2, and this, suppose the first line is parallel to vector b1 and the second line is parallel to vector b2, and angle between these two lines is theta. Okay, so guys, angle between these two lines and angle between these two parallel vector will be same. Okay, अब इन दो लाइन के बीच का एंगल हमें चाहिए, तो मैं इन दो पैरेलल वेक्टर के बीच का एंगल फाइंड कर लूंगा, राइट? सो एंगल बिटवीन टू लाइंस विल बी कोसाइन ऑफ थीटा. हम कॉस के टर्म्स में इसको फाइंड करते हैं, और डॉट प्रोडक्ट वाला रूल आपने वेक्टर चैप्टर में पढ़ा है. सो कॉस थीटा विल बी डॉट प्रोडक्ट ऑफ b1 एंड b2, b1 vector and b2 vector, which will be divided by magnitude of b1 vector and b2 vector. Okay, and अगर आपको इसमें acute theta चाहिए, for finding acute value of theta, we will have a modulus sign in right hand side. ये मॉड्यूलस के आने से राइट साइड अब इसमें पॉजिटिव हो जाएगी, और जो थीटा हमारा आएगा वो हमारा एक्यूट एंगल आएगा. ओके, सो this is the formula for finding angle between two lines. This is the formula for vector form. Suppose Cartesian form is given. Suppose the equations are given in Cartesian form. Okay, so two equation will look like this: x minus x1, y minus y1, z minus z1 divided by a1, b1, c1, x minus x2, y minus y2 and z minus z2 divided by a2, b2 and c2. Okay, so guys, in this situation cos theta is equal to dot product of b1 vector and b2 vector. So b1 vector is a1i, b1j, c1k, and this b2 vector is a2y, b2j and c2k. So the dot product of b1 and b2 will be a1 a2 plus b1 b2 plus c1 c2 divided by magnitude of b1. The magnitude of b1 will be square root a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square, and modulus will be there in the right side. So guys, let's take an example. Let's say there is an equation r vector equal to 2i plus j plus k plus lambda 3i minus j plus 2k, and there is another equation r vector equal to 4i plus j minus k plus mu 2i plus 2j plus k. And suppose we have to find acute angle between these two lines. So for that, first of all, we need to identify vector b1 and vector b2, because for finding the angle we have a formula cos theta equal to b1 and b2 का dot product, which is divided by their magnitude and modulus का sign in right hand side. So b1 vector is, this is b1 vector and this is b2 vector. So 3i minus j plus 2k. b2 vector is 2i plus 2j plus k. Okay. So the dot product of b1 and b2 will be 6 3 into 2 minus 1 into 2 and 2 into 1. So this is 6 minus 2 plus 2. 6 minus 2 plus 2, and answer is 6. Okay, then we need magnitude of b1 and magnitude of b2. So for that, magnitude of b1 will be whole square of 3, whole square of minus 1, and whole square of 2. This is root 14. And magnitude of b2, this is 4, 4 and 1. This is root 9, which is 3. Okay. Okay, now putting all these values in the formula, we will get cos theta equal to 6 in numerator, which is divided by root 14 and 3. So answer is cos theta is equal to 2 upon root 14, and theta is cos inverse 2 divided by root 14. So guys, this is how we find angle between two lines in 3D space, right? So now moving forward, moving to next topic, next concept. Next concept is very important for all the board students. Shortest distance between two skew lines. अब यहां पे स्क्यू लाइंस का क्या मीनिंग है? सबसे पहले हमें वो पता होना चाहिए कि स्क्यू लाइंस किसे कहते हैं, है ना? What is the meaning of skew lines? Two lines are skew. Two lines are skew if they are neither parallel and nor intersecting. If they are neither parallel and nor intersecting. When we talk about 2D space, जब 2D space की बात करेंगे, so we know that two parallel line never intersect each other, right? But suppose if two lines are not parallel, then they will be intersecting, right? अगर दो लाइन पैरेलल हैं तो वो कभी इंटरसेक्ट नहीं करेंगी, बट अगर पैरेलल नहीं है तो कभी ना कभी तो इंटरसेक्ट करेंगे, ओके? बट जब हम 3D स्पेस की बात करते हैं, इन 3D स्पेस two lines can be intersecting, two lines may be parallel, but two lines can be neither parallel and nor intersecting. In that situation, that will be skew lines. Let's take an example of two lines. Let's say there are two lines in this 3D space, right? सामने से देखेंगे तो लगेगा कि they intersect each other, right? But हम 3D space की बात करते हैं. अगर थोड़ा सा इस 3D स्पेस को घुमा दिया जाए तो आप देखेंगे कि ये जो दोनों लाइंस हैं वो दोनों एक दूसरे को इंटरसेक्ट नहीं करती हैं, राइट? ये एक दूसरे को इंटरसेक्ट यहाँ पे नहीं कर रही हैं. बट आप ये भी देखेंगे कि दीज टू लाइंस आर नॉट पैरेलल. ये पैरेलल भी तो नहीं है ना, पैरेलल भी नहीं है और इंटरसेक्टिंग भी नहीं है. देयर इज सम डिस्टेंस बिटवीन दीज टू लाइंस. इन दोनों लाइन के बीच में कुछ ना कुछ डिस्टेंस आपको देखने को इधर मिलने वाली है यार. सो गाइस, इसी तरह की जो लाइंस होंगी वो क्या होंगी, वो स्क्यू लाइंस होंगी। हमें लगेगा कि वो इंटरसेक्टिंग है, हमें लगेगा कि वो दोनों लाइन कैसी हैं, इंटरसेक्टिंग है, बट दे आर नॉट इंटरसेक्टिंग, देयर इज सम डिस्टेंस बिटवीन देम। ओके, तो वही जो डिस्टेंस है वो हमें इनके बीच में फाइंड करना है। हमें इन दोनों लाइंस के बीच की ये जो डिस्टेंस है, इस शॉर्टेस्ट डिस्टेंस को फाइंड करना है। सो व्हाट इज द फॉर्मूला फॉर फाइंडिंग द शॉर्टेस्ट डिस्टेंस बिटवीन टू स्क्यू लाइंस? So there is a very simple and very small formula for finding that. Formula is a2 vector minus a1 vector dot product with b1 cross b2. Okay, and this entire expression is divided by the magnitude of b1 cross b2, and answer should not be negative, so we will apply a modulo sign in this expression. Okay, so for example, let's say we have to find the shortest distance between two lines 2i plus j plus k plus lambda I plus 2j plus 3k and 3i plus 4j plus mu 2i minus j. Okay, and we have to find shortest distance between two lines. Okay, so guys, first of all you need to check if these two lines are parallel or not. सबसे पहले चेक करो कि क्या ये दोनों लाइन पैरेलल है कि नहीं है। कैसे चेक करेंगे पैरेलल है कि नहीं है, कैसे चेक करेंगे? तो आपने करना क्या है, आपने इसके b1 वेक्टर को देखना है। देखो आप यहाँ पे सबसे पहले लिखिए a1 vector is 2i plus j plus k, a2 vector is 3i plus 4j, b1 vector is I plus 2j plus 3k and b2 vector is 2i minus j. Okay, 2i plus j plus k, 3i plus 4j, I plus 2j plus 3k, 2i minus j. Okay, so first of all you need to check whether two lines are parallel or not. Okay, this formula is only applicable when two lines are not parallel. Okay, parallel की situation में we have a different formula. Okay, तो यहाँ पे आप देखेंगे कि ratio of 1 and 2, ratio of 2 and -1, ratio of 3 and 0, these three terms are not proportional, right? So it means these two lines are not parallel. Two lines are not parallel. Okay, so now guys, according to this formula we should have a2 minus a1, then we need b1 cross b2, then we need the dot product of these two vectors, and then we have to find the magnitude of b1 cross b2. Okay, so guys, according to this formula, first of all we will be finding the value of a2 minus a1 vector, right? Then we will find b1 cross b2 vector. Okay, then we need magnitude of b1 cross b2, and then we will find the dot product of a2 minus a1 with b1 cross b2, and after that we will apply this formula that distance is equal to a2 minus a1 dot b1 cross b2, and this entire term is divided by b1 cross b2. Okay, so now the value of a2 minus a1 will be 3i minus 2i, 4j minus j, 3i minus 2i, 3 minus 2, 1, 4 minus 1, 3, minus k. Then this is a2 minus a1. Now we have to find b1 cross b2, and for that in first row we will write I, j and k. In second row we will write the direction ratios of b1 vector, which are 1, 2 and 3, 1, 2 and 3, and then the direction ratios of b2 vector, that is 2, -1 and 0. So this vector will be, this determinant will be I 0 plus 3 minus j. First row and second column will be eliminated. 0 minus 6, then k. First row and third column will be eliminated, so minus 1 minus 4. So now this is 3i plus 6j minus 5k. Okay. Now we have to find the magnitude of b1 cross b2, which is 9, 36 and 25. So this will become 36 plus 9, 45, 45 and 25, root 70. Okay. So and at the last, we need the dot product of a2 minus a1 and b1 cross b2. a2 minus a1, I plus 3j minus k, and b1 cross b2, 3i plus j minus 5k. So 1 into 3, 3 into 6, and minus 1 into minus 5. So this will become 3, 18 plus 5, 21 and 5 will be 26. So guys, this is a2 minus a1 dot b1 cross b2. Now at the end, we will put all these terms in this formula. The dot product of a2 minus a1 dot b1 cross b2 is 26, and the magnitude of b1 cross b2 was root 70. Root 70. So guys, this is the distance between these two skew lines. Okay. So guys, this is the situation when two lines are neither parallel and nor intersecting. But suppose there is a case when two lines are parallel, and now we have to find the distance between two parallel lines. Distance between two parallel lines. So first of all, we need to understand that whenever two lines are parallel, then in this situation, two lines will have equation in this form, where this b1 vector will be parallel to b2 vector. Okay. And now the formula for distance between two parallel lines will be a2 minus a1 cross product with b vector and their magnitude, and divided by the magnitude of vector b. Okay. So let's say there are two lines. First line is r vector equal to I plus j plus lambda I plus 2j plus k, and second line is r vector equal to 3i plus 2j plus mu 2i plus 4j plus 2k. And now we have to find distance between two lines. So guys, first of all, we need to check whether two lines are parallel or non-parallel. Okay. So for that, we will first of all write the values of a1, a2. a1 is I plus j and b1 is 3i plus 2j. Okay. b1 vector is I plus 2j plus k, and b2 vector is 2i plus 4j plus 2k. And as you can see, the direction ratios of b1 vector and b2 vector both are proportional. You can see 1 by 2, 2 by 4 and 1 by 2. All these ratios are equal. They all are proportional. So I can say this b2 vector is twice of b1 vector. So two lines are parallel. So now we have to apply this formula for finding equation between finding the distance between these two lines. Okay. अगर ये दोनों लाइन पैरेलल नहीं होती तो उस सिचुएशन में हम ये फॉर्मूला यूज करेंगे. ओके. So now since two lines are parallel, so now we have to find, first of all we need to find a2 minus a1 vector. a2 minus a1, it means 3i minus I, 2i, 2j minus j plus j, 2i plus j. Okay. Now we have to find a2 minus a1 cross with b vector. So in first row we will have I, j and k. In second row, direction ratios of a2 minus a1 vector which are 2, 1 and 0. Then direction ratios of b vector. So यहाँ पे एक क्वेश्चन आएगा कि b वेक्टर कौन सा वेक्टर लिया जाए, b1 या b2. तो इस सिचुएशन में याद रखिएगा आप इन दोनों में से किसी भी एक वेक्टर को चूज कर सकते हैं एज b वेक्टर. ओके, अब वो b1 हो सकता है, इट कैन बी b2. ओके, सो लेट्स टेक b1 वेक्टर 1, 2 and 1. 1, 2 and 1. So ये बन जाएगा I 1 minus 0 minus j. First row, second column 2 minus 0. Then k. First row, third column 4 minus 1. So this is I minus 2j and 3k. Okay. So and last each we also have to find a magnitude of a2 minus a1 cross b. The magnitude of this vector will be 1, 4 and 9, which is root 14, and the magnitude of vector b will be 1, 4 and 1. 1, 4 and 1, which is root 6. So guys, distance between two parallel lines, formula is a2 minus a1 cross b, its magnitude, which is divided by magnitude of vector b. And guys, value of numerator is root 14, and in denominator we will have root 6, which will become root 7 by 3. And this is the distance between these two parallel lines. So बच्चों, ये है पूरा कॉन्सेप्ट लाइंस का. ओके, अब हमारा नेक्स्ट कॉन्सेप्ट होगा प्लेन्स का, बढ़ेंगे उसकी तरफ.